A video for S1 mock paper for 9709 CIE A level. The first question, he says the number summary of n values 50. So n is 50. This is based upon the concept called as coding. Now find the standard deviation of x. So I'm going to find the standard deviation for the coded values. The formula for standard deviation is greater to sigma x minus q whole square upon n minus sigma x minus q upon n whole square. So when I substitute those values, I should be getting it as 14235 upon 50 minus 700 upon 50 whole square. Simplify that, you should be getting 9.42. Three significant figures. This is the original standard deviation, because in coding, either subtraction or addition, the standard deviation does not change. Given that sigma x is 2865, find the value of q. So we know that coded mean equals to original mean minus q. So coded mean is sigma x minus q upon 50 equals to sigma x upon 50 minus q, which is 700 upon 50 equals to 2865 upon 50 minus q. This gives me q value as 2865 upon 50 minus 700 upon 50, which is 43.3. Now, second question, find the number of ways in which a committee of 6 people have to be chosen. Chosen means C, from 6 men and 8 women. So at least 3 men and 3 women. So it can be done in 6C3 times 8C3, which is 1120. A different committee of 6 people is to be formed from 6 men and 8 women. 3 of 6 men are brothers. Find the number of ways in which this committee can be chosen if there are no restrictions on number of men and women, but it includes no more than 2 brothers. So it can include 0 brothers, it can include 1 brother, it can include 2 brothers, but it should not include 3 brothers. Means from total, if at all I take it away, 3 brothers, the ways in which 3 brothers are selected, it will be getting the answer. So total is, I have 14 people, I have to select 6 people, 14C6. Now 3 brothers are included. If 3 brothers are included, the 6 men will become 3 men, and totally I have to include 3 more only, because already 3 has been selected. So this becomes 11 and 3. So from 11 I have to select 3, 11C3. So when I simplify that, it will become 2868, 2838. Find the number of ways in which the different arrangements of the letters cocoa need. Cocoa need. How many are there? 8. 8 can be arranged in 8 factorial, and we can see that there are 2 C's, so divided by 2 factorial, and there are 3 O's divided by 3 factorial. This is going to be the answer as 3360. Find the number of different arrangements of the 8 letters of the word cocoa need. Again, cocoa need, in which the first letter is O and the last letter is N. So first letter is O, 1, 2, 3, 4, 5, 6 and N. So O is done and N is also done. So I'm left over with 1, 2, 3, 4, 5, 6 places. 6 places, and how many alphabets? 1, 2, 3, 4, 5, 6 alphabets. 6 places, 6 alphabets can be done in 6 factorial ways. Now in this 6 factorial, there are 2 O's, so divided by 2 factorial, and there are 2 C's divided by 2 factorial. So answer is going to be 180. Find the probability that the randomly chosen arrangement 8 letters word cocoa need has all 3's O together, given that 2 C's are next to each other. Given that 2 C's are next to each other. Whenever it is given that goes to the denominator. 2 C's should be next to each other. C, C. So then what else is left over? O, 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 N, E, D. So how many are there? 1, 2, 3, 4, 5, 6, 7. So they can be arranged in how many ways? 7 factorial ways. Out of that, Three e's are there, so divided by 3 factorial. But now all three o's are should be together. So first of all the c's are together, and now the o's also should be together. Now n, e, d. How many are there? 1, 2, 3, 4, 5. This 5 can be arranged in how many ways? 5 factorial ways. That's all. That's going to be the answer. So simplify that. You should be getting 0.143. The time taken in minutes to complete a cycle race by 19 cyclists each. For each two clubs, cheetahs and panthers are represented by this stem and leaf diagram. Find the median for cheetahs. How many are there? 19. 19 plus 1 divided by 2. 20 divided by 2, 10th term. Which is a 10th term? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10th term is 99. So 99 minutes. Find the interquartile range. So in this 10 terms, what is this? 10th term. There are 9 terms on the left side and 9 terms on the right side. Now the middle number for this 9 terms, 9 plus 1 divided by 2. The fifth term. Fifth term is going to be the Q1. 1, 2, 3, 4, 5. So 83. So Q1 is going to be 83. Now the next, what is this? Fifth term on the right hand side. So 1, 2, 3, 4, 5, which is again nothing but what? 106. So Q3 equals to 106. So what is the interquartile range? Interquartile range is 106 minus 83, which is going to be nothing but how much? 23 minutes. The median and the interquartile range of panthers are 103 meters and 14 minutes. Make two comparisons. So the first comparison is, we can see that cheetahs are faster. Cheetahs are faster than panthers. Then the interquartile range is just only 14 minutes, whereas it is 23 minutes. So times for cheetahs are more spread, because the interquartile range is more than times for panthers. Another cyclist, Kenny from Cheetah, also took part in the race. The mean time of taken by 20 cyclists for the Cheetah is, what is this, 99 minutes. So sum of times of cheetahs divided by 20 equals to 99. So when I add all these 19 people, how much am I getting it out? I am getting it out 1862. 1862 plus that 20th cyclist, we don't know. Maybe that guy is Kenny. Kenny divided by 20 equals to 99. So 1862 plus Kenny equals to 1980. So time for Kenny will be 1980 minus 1862, which is 118 minutes. Question number 5. The population of 150 villages in UK is given. Draw the histogram. So first of all, we have to make continuous. So this is 50, subtract 50 and add 50. Subtract 50 from this side, add 50 to this side. Subtract 50 from left side, add 50 to the right side. Subtract 50 from left side, add 50 to the right side. Subtract 50 from the left side, add 50 to the right side. Now we come to know the class width. Class width is 800 over here, 400 over here. Subtract these two, that is the class width. And 800 over here, 1200 over here, and 1600. I have to find the frequency density, which is 8 upon 800, 12 upon 400, 50 upon 800, 48 upon 1200, and 32 upon 1600. So what will be the class width? 0.01, 0.03, 0.0625, 0.04, 0.02. Now I have to draw the histogram for this. So what am I going to do? This is population and this is frequency density. What am I doing? Because it is from 50, so I start 50 and class width is either 400 or 800. So if I take for example, you need to try and check. If at all I take 400 as the class width, 450, 850, 1250, 1650, 2050, 2450. So I'm not able to cover all. So what am I going to do? I'm going to take half of it. So double of it. So this will become 850, then 1650, 2450, 3250, 4050 and 4850. So see, everything is covered. Then 0.01, 0.02, 0.03, 0.04, 0.05, 0.06. Now between 50 to 850 it is 0.01. So over here 0.01. Then 850 to 1250 it is 0.03. 1250 will be in between. So in between 850 and 1650 it will be 0.03. It is 0.03, so I erase this part and go up to 0.03. Then between 1250 to 2050 it is 0.0625. 1250 to 0.0625, so approximately more than this one. It is 0.0625 till where it is 2050, not 2050. So I should draw only till 2050. So middle of that. Then 2050 to 3250 is 0.04. Till 3250 is 0.04. And finally 3250 to 4050 is 0.02. This is going to be the histogram. Write down the class interval which contains the median. So there are 150 villages. 150 divided by 2 is 75. 75th observation. So for that, find the cumulative frequency. This is 8, 8, 20, then 70, 118. So 75th observation will come between 2050 to 3250. So it is 2100 to 3200. Find the greatest value of the interquartile range. So 150 divided by 4, which is 37.5, which is 38th observation. It comes between 1250 to 2050. Next, 150 divided by times 3 upon 4, which is nothing but what? 113th observation. It comes between, for Q3, it comes between 2050 to 3250. I want the maximum. So smallest from here, largest from there. So 3250 minus 1250, which is going to be 2000. Question number 6. In a group of 25 people, there are 6 swimmers, 8 cyclists, and 11 runners. I have to select it out 7 people. From these 25, it should contain exactly 1 swimmer, at least 4 cyclists, and 2 runners. So the next 1 swimmer and include the cyclist, increase the cyclist 5 and 1 runner 1. Whereas 1, 6, 0. That's all. These are the only possible ways. So 6C1 times 8C4 times 11C2 plus 6C1 times 8C5 times 11C1 plus 6C1 times 8C6. So which is becomes 23,100 plus 3,696 plus 168, which becomes 26,964. For another competition, a team of 9 people of 2 swimmers, 3 cyclists and 4 runners stand in a line. How many different arrangements can be there if all the 2 swimmers stand together? 2 swimmers are standing together, 3 cyclists are standing together, and 4 runners are standing together. So there are 3 units. So 3 factorial. 2 swimmers can be done in 2 factorial. 3 cyclists can be done in 3 factorial. 4 runners can be done in 4 factorial. Multiply all those. You should be able to get that answer as 1778. In how many different way arrangements can these 9 people if none of the cyclists stand together? So there are 2 swimmers, 3 cyclists, runners 4. So first swimmer, swimmer, runner, 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 runner. They can be arranged in 6 factorial ways. How many alternate places are created? 1, 2, 3, 4, 5, 6, 7 places. And how many cyclists are there? 3 cyclists. So 7p3. It becomes 151200. Question number 7. Find the total different arrangements of 10 letters word Casablanca in which 2 C's are not together. So I want not together. So what do? Total minus together. Total will be 10 factorial divided by, what is this? 2 factorial. Why this 2 factorial is for C's, and 4 factorial, why it is for A, minus, now they are all together. The C's are together. C and C should be together. Then A, S, A, B, L, A, N, A. So how many are there? 9 factorial divided by 4 A's are there. So 4 factorial. That's all. Simplify that. You should be getting 16,480. Find the number of different arrangements in the 10 letters word Casablanca in which have an A at the beginning and A at the end and exactly 3 letters between C and this. So A at the beginning, A at the end, and it is A at the beginning and A at the end, and between C and C there are 3 alphabets exactly. So this is the condition now. What should I be doing it out? How many remaining alphabets are there, if at all, out of this Casablanca? Casablanca. A, C, C are used away. So what is left over? 1, 2, 3, 4, 5, 6. The 6 can be arranged in how many ways? 6 factorial. In that, we can see that there are 2 A's. So therefore, divided by 2 factorial times, again, what is this? I should be multiplying with 4. Why should I be multiplying with 4? Over here 4, 1, 2, 3, 4, these 4 places I can choose it out any 4 of those cases, therefore it is 4 multiplied by 4. When I simplify that, I'll get 1440. 5 letters are selected from the 10 letters word Casablanca. Find the number of different selections in which the 5 letters include at least 2 A's. So first of all, I'll include 2 A, at least 2 A's. So I'll be including it at 2 A's. So what is this? 2 A's, 1, 2, 3. So Casablanca. So 2 A's. So this A is gone, this A is gone. So another A's I should not be using it out. And what is this? At most 1 C. So for example, I'll be using it out 0 C. So it will become A. So C is also not there. This C is also gone, this C is also gone. So I have to have how many? 1, 2, 3, 4. Out of 4, I have to select 3, 4C, 3. For example, it is 1C is there. Then it will become AAC and 2 more. So again, it should be 4C, 2. that is for 2A's. Next is nothing but what? 3A's. A, this is again 0C. A, 0C is 0C again. I should be doing it out again. 4C2, 1C. C and 1. So it has to be 4C1. Now 4A's. A and 0C. 0C will be A and 0C will be 4C1. And 1C, A and C, it is only one way. So totally add it out 4C2 plus 4C3 plus 4C1 plus 4C2 plus 4C1 plus 1, which is going to be 25 ways. That's going to be the answer. So that completes this paper. See you in the next video. Bye.